Welcome to the Machine Learning for Product Quality Commercial Engineering Accelerator. A CSE or Commercial Software Engineering Accelerator is a package of assets, primarily source code, integration and release pipelines, as well as modularized presentations covering the content, specifically focused on an industrial area. In this case, we're focusing on the manufacturing of products and specifically product quality in that manufacturing process and leveraging machine learning for analyzing the quality of the products being produced. This introduction is going to cover the introduction of industrial trends and a variety of things. But more importantly, we're also going to cover some of the modules that are going to be recorded as well. In this package, there's the introduction, this video. We will also have deep dives on the following sections. So there's the design and architecture, which will be a deep dive into the hows and whys of the design and architecture decisions. We'll cover the data stream, data coming in, its transformation, its storage, its analysis, where it goes. There's a package of code that gets distributed. We'll do a deep dive into that package, how it was made, how it's packaged, why we even did that. There will be a module specifically on the machine learning and data science. In this series, in this introduction, we're going to talk a lot about decision points you have to make. And those are based a lot on what you can actually do, and we'll be referencing the machine learning and data science section. So if there's a really important section to watch and learn about, it'll be the machine learning and data science section. Inference function, this basically is the result of the machine learning. It's taking those algorithms that get developed in that process and then actually running them on the live data stream. So it's all about that section of code. There's a web application. Ultimately, this is where the value is and is surfaced, as well as the DevOps, the continuous integration and release. So we've got a variety of modules and we'll cover all of those. So why did we build this accelerator? Well, first, let's talk about some of the industrial trends in the manufacturing space, specifically that are popping up in the machine learning area. Some key focus areas that we're seeing are around quality detection of the products, operational efficiency for the manufacturing of those products. Preventative maintenance sort of fits in with operational efficiency. It's basically, can I detect that machine's going to go down before it goes down so I can improve my operational efficiency? Might fit in there. Supply chain management is another big one, as is compliance. For this particular accelerator, we're really focusing on the quality detection and the operational efficiency. We didn't really inherit preventative maintenance. So by focusing on quality detection, we were able to also sort of inherit operational efficiency. Key challenges and things to be aware of. These are things that we see with a variety of our partners. The top three are really, really critical. Low margins per solution. So having to maintain a single solution that by itself doesn't necessarily have a lot of ROI, but being able to maintain a series of those provides a significant amount of ROI. So being able to kind of compact how much my costs are from human resourcing to maintenance to compute so that I can actually get out more of the return that I'm looking for. Labeled data has been a big problem. We've got a whole section on that inside of this, so we'll talk more deeply about what that means and what that is, but essentially it's inability to correlate source information with result, cause, and effect. Skilled workers, this is a big challenge as well. Inevitably, what happens is we'll be working with a partner and 6 months, 9 months, 12 months later, that skilled worker is picked up by another company, moves on. There's just not a lot of people who know how to do these types of solutions. And when they do finally get good, they tend to get picked up or move on, which is a big challenge. So making sure that we address the concept of reducing the skill level required to deliver solutions like this. Security and compliance is always a big challenge. True ML ops. So DevOps is challenging enough. Adding the fact that I've got assets that are generated by data and that data is dynamic and changing and updating is also challenging. Then also being able to realize that, hey, I have to have multiple environments for this. So that's kind of a big thing. We address that as well. Code replication, we'll address that, as will we address testing. But overall, that's a big list of key challenges, and we're looking to address that in this series. Typical scenarios that we're looking at specifically in the machine learning for manufacturing space, holistic product quality determination. So I'm building a big product. It's composed of a variety of sub-assemblies. I want to know the holistic product quality determination, not necessarily that like this little widget over here is messed up. I want to know that the whole thing is good or the whole thing is bad, and not necessarily caring about the little bits that made it up. There's product subcomponent quality determined. I'm building subcomponents that are then going into this. I want to be able to determine that subcomponent is bad, and I may or may not want to roll that up into the holistic assembly. Process quality determination, that's more focusing on the process manufacturing the good as opposed to the good itself. And then equipment preventative maintenance. Time is money. Equipment goes down. That's a pretty important and typical thing. If I can tell you that 2 weeks from now that machine has a high risk of going down and you can schedule that in with your normal maintenance, it's less likely to go down at an inconvenient time. Outcomes, really it just boils down to these two things: is reducing product quality issues and improving your processes. So operational efficiency, running leaner, meaner, faster, more cost effectively, and having less bad equipment go out the door. Less bad goods means better brand, lower costs on fixing, and all those kinds of things. The class of solution is important for a couple of reasons. One is scale. The way the solution scales is different. An ISV solution does not have a predefined scale and starts small and then grows. An internal solution is typically easy to fully define the speeds, feeds, and the factories up front. So that makes it a little bit easier to scope out the entirety of the project. Also, it's going to be single tenant. Data. The formats of data are less easily defined in the ISV space. If I'm a ISV, that means I'm onboarding many customers who have many factories, and there may or may not be standardization between those. If I'm an internal solution and I'm a specific factory or manufacturer, I already know up front what all my data formats are, or they're more easily obtained. Onboarding is another challenge. The ISV space, you have to expect that you have a services team, you have a maintenance team, you have to go through a sales cycle. There's a significant amount of additional complexity in onboarding. Internal solutions, that development team is the onboarding team. So typically their dev environment, they can just fork a data feed and start going straight for it and providing value immediately. Also, your iterations are a lot faster. ROI is an interesting one. The ISV space, the cost can be distributed across multiple customers. So the margin question is a lot easier to address. So low margin solutions are easier to implement with an ISV because they're distributing their costs across a larger customer base. The internal solutions, there's a lot of additional influential points and impacts around it, but also it's a single source of return, right? Like, if I build this, I have to generate enough return for myself. So some solutions may make more sense for an ISV to solve, while some solutions might make more sense for an internal or a factory or manufacturer to solve. Internal solutions for many customers have a dev and a prod. Sometimes it's just prod. ISV scenarios might have multiple rings of releases. as well as multiple rings of releases per customer. Internal solutions, though, they tend to just have less restrictions. When I go with a customer and they're building it for themselves, there's cases where their dev environment is prod. But then in the ISV space, typically there's going to be a dev, an integration, a QA, and a prod, typically at a minimum. So complexity from how many environments, their DevOps, CI/CD, there's some key things to think about in that space as well. There are typically two types of algorithms that you can use. One of them is a multi-system correlation. That's I'm bringing in data from my manufacturing process, and I'm bringing in data from my maintenance records, or I'm bringing in data from my returns. And I'm creating a correlation between the telemetry from the manufacturing process and the data from my returns or from my testing systems, and I'm able to create this correlation. And if I can create that correlation, that means during the manufacturing process, I can possibly predict the result that's going to come on the other side of it. That's a really wonderful thing. So I'm using downstream data to make upstream decisions. The big pros of this are it's a really great thing to do. It's very well documented. There's tons of examples out there. So if you have this ability already set up, go for it. The downside of this is that usually there's not enough data, and it requires significant investments to actually collect that data and label that data, correlate that data, and there's still no guarantees that at the end of the day, you're going to be able to create an algorithm that has significant enough results to be useful, and deliver value. And that's where the anomaly detection with trend overlays comes in. This is a really wonderful thing to get started with. I highly recommend this. In fact, our solution in this accelerator uses anomaly detection and trend overlays to help bootstrap, because you can get in with a much lower investment and start delivering value promised in the machine learning and data space quicker. And then that'll kind of increase the appetite for creating more sophisticated algorithms. And it can help create an incentive for, well, now what if I start labeling this? What if I connect the system? You can start improving these, but at least getting this one out the door first gives you a stepping stone into this world. So the big pros are that you actually don't have a need for the downstream data. Your data collection and labeling requirements basically go away. You just need to fork your data feed and drop it into an archive for analysis. And that analysis doesn't need to be correlated to really anything. The big cons are that the training schedules can be a bit tricky. Automating collection and toss out can be a little bit tricky. And then knowing which knobs to tweak. Even in the anomaly detection space, there are knobs and you need to be able to tweak those. So making sure that you know what those knobs are and how to tweak them, that can be a little bit tricky because you don't know how many different things. So, an anomaly might not necessarily actually be an anomaly. It's just something that kind of goes wrong every now and again, and it's well represented in your data set. So it's not actually anomalous. You're just looking for issues, but you're calling it an anomaly. So there are some kind of nuanced things to keep an eye out for there, and I'm going to stick those in the cons category. All right, finally, here we have a demo of what the entire application looks like. This is the web application. It's Python based. Behind the scenes, it's actually running a data feed. It's producing 1 and 100 is an anomaly. And it's going through the whole process that it normally would. Typically, you've got telemetry. It comes in through some type of event hub, an IoT hub. It hits a stream analytics. It transforms the data. It then pushes that data into a machine learning algorithm, and that algorithm then pings the website for the feed of anomalies. So you have a live feed here, that's socket connection. and then drops the results, good, bad, and bad, into a SQL database. So here on the left, we have the anomaly feed, so we can see that this particular widget ID, whatever that is, was an anomaly. And it has some cool charts here, just stuff that play around with. So main thing is we're focusing on quality detection. So we're displaying the widget that was classified as anomalous or not up to the quality bar. We have a list of all the widgets, whether they were good or not. We can roll that up into how individual lines performed. So we've got 4 factories, each factory with 3 different lines. We can see the percent of anomalies that each one has produced and the deviation and the trend of those anomalies. Now, you'll hear more about this in the machine learning section. We actually had to have a change of algorithm use during this project. I thought we'd get to use a more classical anomaly detection where you do deviation type stuff. That didn't actually work out very well. So we'll have to change that. That's going to be coming. You will still get trends though. In the factory overview, basically it's just a roll up, right? So now you get percent anomalies and a trend per factory. So this is where you start to be able to inherit some of the operational efficiency capabilities when doing an individual product quality assessment. So I've got all these products. I know which manufacturing line, which factory, and whether it was good or bad. I can then roll all those up into the lines, and then I can roll all the lines up into the factories. And that's how you achieve it. So that ends the introduction for this accelerator. I hope you guys stick around and check out the various modules that we also have. Feel free to ask questions and post issues into the GitHub, and definitely let me know if you are using this for your own factories or scenarios. Thank you very much.